Objectives of today's lecture will enable you to understand reactions of alkenes including hydrohalogenation, hydration, halogenation and halohydration. The second chemical reaction that we are going to study is hydrohalogenation, means addition of hydrogen halide across the double bond. Alkene reacts with aqueous solution of halogen acid, means HX, to form alkyl halide. The order of reactivity of halogen acids is that hydrogen iodide have a greater reactivity order as compared to hydrogen bromide, which in turn have greater reactivity order as compared to HCl, hydrochloric acid. Let us look at the chemical reaction. This is an alkene and this is a halogen acid. Now this H and X atoms from halogen acid is going to add across this double bond. As you can see over here, an X atom have been added and this CH2 have converted into CH3. Again converting an unsaturated hydrocarbon to a saturated alkyl halide. Similarly, in the next example you can see that hydrochloric acid is going to add across ethene, giving you ethyl chloride. Now students, let us look at the mechanism through which the halogen acid adds across the double bond. You know that alkenes acts as nucleophile because they have pi electrons over here. This pi electron is going to broken down from here and make a bond with hydrogen atom. The complete arrow is showing a transfer of this pair of electron. And this bond is going to broken down in a heterolytic cleavage, and this whole bond between H and X is going to transfer on this halogen atom. Now you can see an intermediate is formed. This carbon is being deprived of the electronic density, is going to carry a positive charge because you can see carbon over here is making 3 bonds, whereas the other carbon atom is making a bond with this hydrogen atom and its valency is satisfied. Now this X atom is carrying a complete negative charge which can act as a nucleophile now. Now you can see that here a carbocation is formed carrying a positive charge, and over here we have a nucleophile carrying a negative charge. So these electrostatic forces of attraction can be created, and this halide ion is going to attack on this carbon atom making a bond over here. So this is the mechanism through which a HX halogen acid is added across the double bond. Students, always remember that whenever you are having a symmetrical alkene means that if you are going to divide this molecule into 2 equal halves, you will obtain mirror images, identical halves. So it is a symmetrical alkene. Now when you are going to add hydrogen halide to a symmetrical alkene, it doesn't matter that where the hydrogen goes, either it can attach to this carbon atom or the other one, similarly the X atom. But when you have an unsymmetrical alkene, we have a rule for the addition of halogen acids. Students, the rule is called Markovnikov's rule, which states that in the addition of unsymmetrical reagent, for example HX, to an unsymmetrical alkene which cannot be divided into 2 equal halves, the negative part of the reagent goes to that carbon consisting the double bond which has least number of hydrogen atoms. Let us look at this chemical reaction. Now students, this is an unsymmetrical alkene. You can see this carbon is attached to 2 hydrogens, whereas this carbon of the double bond is attached with 2 methyl groups. So if you are going to divide it from here into 2 equal halves, you will not obtain the mirror images. This is the example of an unsymmetrical alkene. The reagent that we are using is also unsymmetrical, that is HBr. Because if you are going to cleave this bond between hydrogen and bromine, you are not going to obtain equal or mirror images. Now as per the rule, the negative charge of the reagent, which is this bromide ion, is going to add to that carbon of the double bond which is having less number of hydrogen atoms. So this Br is going to add to this carbon atom instead of this CH2 group, which is having more hydrogen atoms. As you can see in the product, 1-bromo 2-methyl propane is not formed because it is not according to the rule. Whereas 2-bromo 2-methyl propane is the actual product according to Markovnikov's rule. Let us start with the first chemical reaction of alkene, which is hydration. Students, you know that addition of water is called hydration. Some reactive alkenes react with water in the presence of suitable substances like acids, which can be sulfuric acid, to form alcohols. It is possible because alkenes are soluble in cold concentrated sulfuric acid. They react by addition, means they add to it to form alkyl hydrogen sulfate. And this alkyl hydrogen sulfate on boiling with water decomposed to give the corresponding alcohol. So it is a two-step reaction. Look at this chemical reaction. You will see that alkene is going to react with sulfuric acid. Over here this is an open structure of sulfuric acid, H2SO4. So this is the structure of sulfuric acid. These two are going to react to give you ethyl hydrogen sulfate. This is ethyl hydrogen sulfate, which upon boiling with water gives the corresponding alcohol, and sulfuric acid is regenerated because it is a catalyst. Students, let us look into the detailed mechanism of this acid catalyzed hydration. So you can see that alkene over here is going to abstract the proton from the sulfuric acid. Why is it so? Because you know that the pi bond of alkenes act as nucleophiles and acids donate their protons. So this pi bond is going to break down and abstract this proton. One of the carbon atoms of this double bond is going to make a bond with hydrogen, which you can see over here, depriving the second carbon from its complete valency. As you can see, it is making 3 bonds over here. Its valency is not complete. It is not making 4 bonds. It is deprived of electronic density. That is why it is carrying a positive charge. On the other side, after the abstraction of this proton, this bond is going to shift on the oxygen atom as a negative charge. So a bisulfate ion is produced, which on the second step is going to attack on this carbocation. A carbon carrying a positive charge is called a carbocation. So a bond is going to form between oxygen and carbon, and it is going to generate ethyl hydrogen sulfate. As we are studying hydration, so students, in the next step, water is going to add to ethyl hydrogen sulfate. Now this water is going to use its lone pair and make a bond with this carbon atom over here, breaking the carbon to oxygen bond. Now this CO bond is going to broken down in such a way that it is going to reside on the oxygen atom as a negative charge. And over here you can see that a complete water molecule is added over here. Normally oxygen makes 2 bonds, remember. But over here oxygen is using its lone pair to make the 3rd bond. So it is losing its electronic density. That is why it is carrying a positive charge. Now in the second step, this negative charge of bisulfate ion is going to abstract this proton. And what is the driving force behind this chemical reaction? It is the positive charge on oxygen atom which wants its lone pair back, because it is going to give it stability. Now this bisulfate ion is going to abstract this proton and shift the lone pair by breaking this hydrogen to oxygen bond, giving the lone pair back to this oxygen atom. In this way you can see an alcohol is formed, CH3, CH2 and OH, alcohol, ethanol, along with sulfuric acid. In this way, sulfuric acid is regenerated. That is why it is called acid catalyzed hydration. Students, for your convenience, these are all the 3 steps that I have explained, and they are represented at one place. The second reaction that we have to study today is halogenation. Now students, alkenes react with halogens in an inert solvent, for example carbon tetrachloride. Now why do we need an inert solvent? So that solvent is just going to provide a medium and not chemically react with our reactants or the products that are going to form at the end of the reaction. This reaction takes place at room temperature and the products are vicinal dihalides. Now what is the meaning of vicinal dihalide? Vicinal means adjacent carbon atoms and dihalides mean that you are going to have halogen atoms on the vicinal or adjacent carbons. Now you can see in this chemical reaction that alkene is going to react with halogens and give vicinal dihalides. If we are taking bromine and chlorine, they are effective electrophilic reagents. What do I mean by saying electrophilic reagents? That chlorine and bromine can add to the nucleophile, so they are electrophile themselves. Fluorine is too reactive to control and the reactions are very vigorous and iodine does not react under these conditions. Now students, let us look at the mechanism of this halogenation which leads to vicinal dihalides. So in the first step, what is going to happen that a bromine molecule becomes polarized as it approaches the alkene. This polarized bromine molecule transfers a positive bromine atom to alkene, resulting in the formation of bromonium ion. This is the chemical reaction in which you can see that as the bromine Br2 molecule approaches this alkene, it gets polarized because its electronic density gets perturbed or disturbed, giving one bromine atom a partial negative charge and the other partial positive charge. Now this pi bond of alkene acting as a nucleophile is going to attack on this bromine atom over here and make a bromonium ion. The other bromine atom is going to take this bond and get a negative charge. Now this negative charge bromine atom is going to attack on this CH2. Why? Because over here we are having an electronegative atom carrying a positive charge. So it wants its lone pair back. In this way this bond is going to be broken down. Now you can see one bromine atom is added at this carbon and the other one on the other carbon atom. And this addition is called an anti-addition, means the bromine atom is added opposite on each carbon atom. Students, this chemical reaction is also used for the detection of double bond in an organic compound. Because as you can see in the second step, when the nucleophilic bromide ion attacks on the carbon of the bromonium ion, over here you can see, to form a vicinal dibromide, this is vicinal dibromide, the color of the bromine discharge, bromine is reddish brown in color, Br2, and as it adds across the alkene, its color gets discharged. So this is also a test that is applied for the detection of double bond in a molecule. Now students, one more thing to remember over here, that whenever a electronegative atom makes a bond with its lone pair, it always gets a positive charge and it makes a transition state, a molecule which is not very stable and it is short-lived. That is why the second bromide ion is going to attack on this carbon atom and give this bond back to Br as a lone pair. Now students, how do we know that bromine is using its lone pair to make an excess bond? As the valency of any halogen atom is -1, so it can make only one bond. But over here you can see that bromine is making two bonds, one that it normally makes and the second using its lone pair. You know that halogens have 3 lone pairs. So bromine over here is using its one of the lone pairs to make an excess bonds, as it is using its own electronic density. That is why it is carrying a positive charge. Remember, whenever an electronegative atom uses its lone pair to make an excess bond, it carries a positive charge. But this state is unstable. It is a transition state. So the bromide ion is going to react with this CH2, breaking this bond between C and Br carrying a positive charge to give its lone pair back and stabilize it. The next chemical reaction that we are going to study is halohydration. Now in halohydration, addition of hypohalous acid HOX, X is a halogen, it can be chlorine or bromine. This can be HOCl or HOBr, is called halohydration. Alkenes react with hypohalous acid to give halohydrin. This is the structure of halohydrin. In this reaction, molecules of the solvent reacts too. For example, water over here is acting as a solvent, but it is going to chemically participate in this chemical reaction. So water in the presence of halogen is going to chemically react with alkene, giving halohydrin and HX, which is halogen acid. Now in halohydrin you can see that this hypohalous acid OH and X is added across this double bond. So this is called halohydrin. Now students, let us look at the detailed mechanism of halohydration. In the first step, this Br2 molecule is going to get polarized while approaching the alkene. One of the Br atom from its lone pair is going to attack on this carbon atom. As a result, the pi bond is going to make a bond with the same bromine atom, making a bromonium ion. For the next bromine atom, this bond between Br and Br is going to reside on this bromine atom, making a bromide ion. In the next step, water molecule is going to add. It is going to make a bond with the carbon atom using its lone pair, making a CO bond. Since oxygen is using its lone pair to make the bond, that is why it is carrying a positive charge. Now the C and Br bond is going to broken down in such a way that this bond is going to reside on the bromine atom as a lone pair. The positive charge over here is going to vanish because bromine is getting its lone pair back. Next, the bromide ion which is formed in the first step is going to abstract the proton from this water. Why? So that it can give this bond back to oxygen atom as a lone pair. In this way, OH is going to add across this carbon atom and Br on the other carbon atom of the double bond. And HBr, halogen acid, is also formed along with a halohydrin. Students, I hope you have understood